So it is expected that it is already being recorded. So
Okay, sir.
yeah. Anyway, so somebody is telling the solution.
Yes, sir. Sir,
Please continue.
general way, we say that when we add two matrices, we add their corresponding elements.
Right.
And when we calculate the trace of a matrix, we add the elements of the diagonal. So when we will add two matrices A and B, their corresponding diagonal elements will also add, and hence their trace will be the sum. We say that the diagonal element for the first row and first column is A1 plus B1 for matrix A plus B.
Yes.
And in generally we will write it an plus bn, and when we will find its trace, we will write summation an plus bn, where n tends from 0 to I, where I is the order of matrix. This will be the trace of a plus b, and on the right hand side we will write trace of a, which will be summation I runs from 1 to n an, and trace of b will be summation I to n bn. I runs from 1 to n bn, and from the property of this sum, we will prove that the both sides are equal of the equality.
Yes. Correct. So whatever you have said, that is fine for this trace of a plus b equal to trace of a plus trace of b. So the earlier person is also telling me that is also correct, but he's taking 3 by 3 matrix or say, because here the order is not specified. So you can take general n by n, a and b are to be square matrices of size, let's say n. You can take a general order. Okay. So and what about this trace of ab equal to trace of ba? So you have told me for plus, right?
Yes,
And
sir.
what about the product?
सर प्लस के लिए जनरल लिया था, इसमें मल्टीप्लिकेशन के लिए 3 by 3 की मैट्रिक्स ली थी इसमें.
अच्छा.
मल्टीप्लाई वो. यस सर.
हाँ, so जनरल दोनों में ही लेना है, ठीक है?
Yes, sir.
You have to take
और
general.
सर मल्टीप्लिकेशन के लिए जो हमारे डायगोनल एलिमेंट्स होते हैं वो हमें इस तरीके से मिलते हैं, जैसे हम ए बी प्रोडक्ट निकालेंगे तो ए बी प्रोडक्ट के लिए हमें डायगोनल एलिमेंट्स मिलेंगे. फर्स्ट डायगोनल एलिमेंट मिलेगा हमें ए की फर्स्ट रो और बी के फर्स्ट कॉलम को मल्टीप्लाई करने पर, और फिर सेकंड एलिमेंट मिलेगा हमें ए की सेकंड रो और बी के सेकंड कॉलम को मल्टीप्लाई करने पर. तो हम इस तरीके से इसे जनरल वे में प्रूव कर सकते हैं.
हाँ, ठीक है. So let us see how to write this. I mean how we can answer this question in general. So for plus it is easy. Whatever you have done, just stick with your notations. So you have taken for, let's say, I am here taking this index I goes 1 to n. So you can choose any notation, but you just stick with those notations. And I am representing this AII, the diagonal elements of the matrix A, because A is Aij, general element, and B by this Bij, and we can add this at the trace of A plus trace of B, because the trace of any square matrix is the sum of its diagonal entries. So in this way you can say, and for the product, you just keep in mind if the ijth entry of the product matrix AB, because AB is also a square matrix. If A and B are two square matrices given, if A is Aij and B is Bij, then how to write a general element of the product of the matrix AB? So in this way you can write it. If A, B, the ijth entry of the matrix, the product matrix AB, can be represented by this summation varies from k1 to n, aik bkj. Okay, so the trace of AB, so you just have to put this j equal to I. So in this way you can say you can write the double summation will come here, because by this definition ABI, and then these two are scalars, AIK and BKI. These two are scalars, so they can commute. I mean you can just write from here. I mean they can commute. So and so this, if you see the definition, this will become the definition of trace of BA. if you multiply this BA, write the ijth entry of BA, then this will become the BKI and AIK. In this way, you can say trace of AB equal to trace of BA. Is this understood to everyone?
Yes, sir.
Yes, sir.
So
Yes,
only
sir.
thing just keep in mind. Actually, for these kind of expression, we take an idea using this example 3 by 3 or 2 by 2 matrix. But if we are going to prove such results, then we have to take general matrix and we have to consider this AB, this notation. I mean, how to represent this product matrix, or let's say square of a matrix, and so on. Keep in mind. So what?
That how they commute.
Sorry.
Repeat
Say it
it.
again.
How they commute every time.
How they commute? I mean, you are asking AIJ, BKI, how they commute?
Yes.
Because
Scalars.
the entries are scalars. So if I give you let's say two scalars, let's say two real numbers. So they are if you let's say x write x into y or y into x, they are same, right? So I have done the same thing here.
Okay.
Okay. So yeah. So is there any other doubt in that problem, or we can move further? Okay, so what about the next part?
नेक्स्ट पार्ट इज बी. इसमें 2 by 2 की जनरल मैट्रिक्स लेके ही प्रूव कर दिया था इसमें.
So here the matrix order is 2 by 2, so you just have to uh, consider only the 2 by 2 matrix, because so right now here you have to prove for 2 by 2 matrix. For general order, it needs more mathematical background. I mean, more tools to say. But for 2 by 2, you can use the definition and you can prove. I mean, so anyone has tried this?
Yes, sir.
Yes, sir.
First entry is 1, then 0, 0, 0 for A, and B 0,
No,
0,
no.
and 1.
So I'm not asking
A11,
for.
A12,
I'm not
A21.
I'm not asking for C. I'm asking for B. So for this, you have to prove. Okay, because it is the question is we have to show this equality. So you don't need to consider an example. You have to take general matrices AB. Somebody is telling. Please tell.
A matrix A11, A12, A21, A22, and B matrix A11, A12, B11, B12, B21, B22. Then AB find
Coming.
here,
Hello.
or then multiply matrix multiplication AB. Then
Yes.
determinant निकाला, और राइट हैंड साइड में भी डेट ए डेट बी अलग अलग निकाल के मल्टीप्लाई.
Then
इक्वल आया.
ठीक है. I got your point. Everybody is getting what she is trying to say.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, it is not. It is easy. I mean, it is not very difficult. You just start
Yes,
with the. You just consider A and B, A11, A12, A21, A22. Similarly, consider B equal to B11, B12, B21, B22, and just see this. Start with the left hand side. You just multiply first AB and then find the determinant of the 2 by 2 matrix, this AB, and just follow some algebraic manipulation, and then you just land up to this right hand side of this equality. You just only need to take care. Okay, what is the determinant of ABCD? So it is AD minus BC. That's it. Okay, that you can prove. For C part,
अभी बता.
सी पार्ट के लिए 2 एग्जांपल ले लेते हैं. ए और बी 1 0 0 1 2 by 2 की मैट्रिक्स थी. 0
हाँ
0 0 1 इन दोनों का ऐड किया तब डिटरमिनेंट अलग था, और अलग अलग का
हाँ
डिटरमिनेंट निकाल के ऐड किया तब उनका
ठीक है,
अल्टीमेट
good, good. You can construct as many example. I mean, different examples also that I mean you can see. Just try at least. Can you construct 5 examples of it? Okay, so that it is better. But okay, one example is fine. One example. Everybody is understood with this. The part C of the problem 16.
Yes,
Yes,
sir.
sir.
Yes, sir.
So how about the question 17?
The क्वेश्चन 17 का आंसर 25 फैक्टोरियल मल्टीप्लाई बाय 10 टू द पावर -9 सेकंड है क्या?
So how, but how you have get this?
सर एक
Sir,
मैट्रिक्स
I
की
kind of
डिटरमिनेंट
did the proof through PMI.
So PMI से proof किया.
Yes.
Sorry, say it again.
I kind of did the proof through principle of mathematical induction.
Okay. How then? How you have done that?
Yeah, I took the, like, for P1, like I took P as our proposition, then I found out P1 and P2, and then I assumed that it's true for P equal to n. So that means that for any mm, nth ordered matrix, we can find the determinant and it will have n factorial multiplications. So when I go about doing Pn plus 1 to apply the PMI, so it's basically whenever we are finding out the determinant, we take one row and then from each element of either row or column, and from each element we kind of that row and that column uh, we exclude it, and then the rest
Yeah.
of the what will remain will be an ordered n ordered
And
matrix.
one
So for
less.
Yes, one less, because I am taking n plus 1 order matrix. So now when I
Yes.
am taking the n plus 1 ordered matrix from one row will contain n plus 1 element, I am taking the row multiplication. So from each element along with that I'll have the determinant of the nth ordered matrix. So there will be n plus 1 n factorial multiplication. So basically it will be n plus 1 factorial when we
Yes.
add it up.
Yes. Yes. This is fine. Perfectly fine. The only thing is that you just write. You just should know what is the definition of a determinant for n by n matrix. Whatever you have said, that is perfectly fine with the arguments. Any other? So this is for part 1. There are two parts in that question. So any other for part 1 of 17? Whatever she said, it is understood by everyone. So okay, let's see. So how we can do. So you can just mention this the function fn. Uh, so we claim that okay, this the determinant can take uh, of this shape. If this k equal to, let's say, 1 to n minus 1, and it is n factorial upon k factorial. Okay, that much this function, that much number of multiplication that we require to find the determinant. So there is the term that cofactor expansion. If you maybe I'm not sure, have you heard this, but you may have seen this time, or at your undergraduate level. This you can represent this determinant of a is the summation of this a jk, that is basically a jk term, and minus 1 to the power j plus k, and this is the determinant of a jk. So this matrix is basically a jk is a matrix formed by removing the jth row and k column in the matrix A. So basically it's a recursive kind of determinant, and it is a technical definition, and we call it as a cofactor expansion. Whatever she said, she's also is said she's also said correctly. So it is like to represent mathematically, you have this equation, this cofactor equation. So you can see here, yeah, here you have like you have to take a sum, and the determinant of this, if the size of a is n, and so here the size of ajk is n minus 1 by n minus 1. And then again, if you see further, So ajk is n-1 by n-1, and it requires n-1 multiplication. So I mean, if you see logically, you arrive to this the relation f of n equal to n times f of n-1 plus n, where f of n was this. So if you I mean see this, so this it will have this n-1 factorial term. So this fn will greater than or equal to n factorial, because you can see if we have why this is the greater than equal to n factorial. uh, because there are some matrices which may have a lot of zeros, so there the computation of determinant will become easy, but not in the every case. Usually if we see the matrices from the real world data, that is not having so much of zero, or not very nice matrix. So mul- uh, that much multiplication we need in factorial. And what about this second part? If the multiplication takes, so have you tried this? Somebody is telling me the answer of the second part.
Yes, sir. Total number of multiplication into 10 raised to power minus 9.
Okay,
Hello.
so what is your answer?
25 factorial into 10 raised to power minus 9.
Second.
20 25 okay, 25 factorial. uh yeah, that okay. So here if you just write, so 25 factorial is a big number. Okay, so in if we try to write that, let's say if I want to approximate that factorial to 25 factorial by 10 to the power 25. Okay, so then we are arriving at this much of time in 3 into 10 to the power minus 9 years. If we follow this, so one multiplication takes 10 to the power minus 9 seconds, then the computation of 25 by 25 I mean size matrix, the determinant will take this much of time. So why this question is put here, just to realize you that the computation of determinant will take so much of time by machine. So by hand it will not be possible, and even this machine will take this much of time. So see this the determinant is a nice function, but it is also very expensive.
Sir,
Mm-hmm.
so here fn is the number of multiplication to find the determinant of n by n matrix. When fn is greater than n factorial.
When fn is
Greater than n factorial.
okay, you are asking, okay, when it is greater than n factorial. So
Yes, sir.
mm-hmm. So basically if you see this summation k runs from k is running, so k varies from 1 to n minus 1. Okay, so if k equal to 1, it is already n factorial, and if k equal to 2, it is n factorial by 2, summing it. Okay, so it is always, fn is always greater than equal to n factorial. If k equal to 1, if k equal to 1, then fn is n factorial. So is it correct? Is it fine?
Sir, how we claim this that f1 f of n equal to this? How we know? Is there any proof?
You just have to see I mean the definition. Do you know this expression? You just have to, I mean just explore more about this expression, this cofactor expansion, in order to
I
get
know
this
this, but
I
I
mean
don't
from
know how does
uh, okay, so if you don't want to, I mean use this fn, you can just answer by that reasoning. you just start with that first row. If you have a n by n matrix, the very first solution that one girl is explaining, that is also fine. You just start with first let's say n by n matrix, and then just put a one. So how will you take? Just fix one row, and then for the corresponding entry you just delete that row and column, and find the determinant of the remaining matrix, and you can see that is the n minus 1 by n minus 1 size. And then again you just and then again for this you need to make at least n minus 1 factorial for the multiplication for that the remaining matrix. So in that way you can answer. If you are having problem with this function fn, so here fn is the number of multiplication required. That is basically a claim that much the number of multiplication we require to find the determinant using the cofactor expansion. So if you are aware with this this cofactor expansion, then you will be able to follow. But okay, just you can say it by that reasoning. For the time being, you just skip this if you are not aware with this the cofactor expansion, or you can search it on Google if you want to learn. I mean, you will be able to follow why I am using this fn equal to this n factorial by k factorial.
Okay, sir.
Sir,
For sheet 2, please mute yourself after telling me.
सर PMI में n is equal to 1 के लिए ये कैसे प्रूव करेंगे कि एक मल्टीप्लिकेशन चाहिए होगा उसमें डिटरमिनेंट?
So what is the determinant of 1 by 1 matrix?
Same element.
Same element. And what is the factorial of 1?
1.
So that is
सर मल्टीप्लिकेशन तो है ही नहीं कहीं पर. सर इसमें मल्टीप्लिकेशन तो नहीं किया हमने किसी के साथ किसी का.
And what is the value for 0 factorial?
1.
1. 1.
Then is it fine?
Okay.
Please mute yourself after telling me your answer. Okay, so moving to other sheet. Now start with the question 1. So before starting the question 1, any of you please tell me what do you mean by a vector space?
कोई भी सेट वेक्टर स्पेस तब होगा जब क्लोजर प्रॉपर्टी होगी एडिशन के रिस्पेक्ट में एसोसिएट ला होल्ड करेगा. Identity inverse commutator.
Start with very elementary level. So first, okay, so first you have, so vector space, for a vector space you should have a set first. You should have a set, then only you
Yes,
can say that it is having some operation or it is having so and so properties. Okay, so you just start with very basic definition. And when do we say a set is a vector space? Because ultimately this set comes into picture. Whatever you learn, like let's say group theory or some other structure, you just first have you with you is a set, and then you just give that set with some operation, some special operation with some special property. It will form some nice structure. So here you call as a vector space. So just first tell me again, what do you mean by a vector space?
Sir, let V be a non-empty set and F is a field. Then we call it a vector space if it is commutative, associative, and have additive identity. And
No. So see, just a minute. So you have said that okay, V with field F and it is closure associative, that you have said. But closure and associative means what?
Sir,
And it is with
commutative.
okay,
Commutative with
commutative and
vector
associative,
addition.
commutative and associative with respect to some operation. But
Yes,
so
sir, with
that
vector
operation should come first. Okay, so you can say that V, when do we say V is a vector space? So V is a vector space if it is having if first of all it is a non-empty set, and then it is having over, let's say, some field F and two operation, that is addition and multiplication, scalar multiplication. Now you can say that it is the commutative associative with respect to that operation. Okay.
Yes, sir.
Please.
With vector addition, it must be commutative, associative, and it must have additive identity and inverse, additive inverse. And then with respect to scalar multiplication, one dot v is equals to v for every v belongings to the vector, the set v.
One
And
is a multiplicative identity, right?
yes, a multiplicative identity of the field. And then we take any c belongings to the field, c dot v is equals to, c1 and c2 belongings to a field, and c1 dot c2 v is equals to c1. It means it should be associative under scalar multiplication, kind of that.
Not you cannot say it is associative, but it is sort of, because
kind of.
yeah. But you can't use the word associative because the one here is a scalar c1 c2,
Yes,
and
sir, yes.
other is a multiplication of a scalar and a vector, so that you should keep in mind. Yes.
Then it should be when we take any c from the field and alpha plus beta any vector, then the scalar multiplication must be distributive over that vector addition. And then we take c1 plus c2 from the field, and the scalar multiplication with the vector is equal to c1 dot v plus c2 dot v.
Yeah. Okay, very good. So everybody is clear with the definition. So whatever he said is it's fine. So you just have to take keep in your mind first the vector space comprising the three quantities. First is the field of scalars. Another is a v. First the set is set of v's. Let's say the set of vectors here. The elements of v, we are calling it as a vectors, and two rules. One is the addition and another is the scalar multiplication. That are following these properties, a few properties that he mentioned. Okay, so so you clear with the definition, and what are the let's say examples? Do you know?
R over R.
That is one example. Yes.
C over R.
C over
C over
R.
R,
Q
C
over
over
R.
C.
R over.
There, so you can see there are various examples, and so have you try to prove that okay, r over c over r, or r over, let's say, r is a vector space, although we say they are vector space. So if you just checked with those properties, these properties, that 8 properties that you have told me, these are 8 properties, right?
Yes, sir.
So have you tried at least for one example, you have tried for all these 8 properties, this verified or not? Because that for the coming question, that much work you have to do.
Yes, sir, it is satisfied
Okay.
for R over R.
ठीक है. Now coming to this question one again. Okay, so this is that's it. For this question one, now you just tell me which of the following form the vector space as it is asked. The plus, so v equal to r3, that is specified, and it is over the field of real numbers, and plus and dot are defined in the respective problems. So for part 1, what is your answer?
Vector space.
Not a vector space. Not a vector space.
Not associative probability.
Commutativity.
So yeah, for checking associativity, it will take like 3. You have to take 3, consider the 3 vectors, but for you can easily see it is not commutative with plus. Okay. Now, so it is not a vector space. That is fine. So in order to say that it is not a vector space, out of these 8 property, if any one of the 8 property will not follow, then you can say okay, this V is not a vector space over the such and such operations. But if you have to show, if you know that this forms a vector space and you have to show that it is a vector space, then you have to check all the 8 properties. That much I want to say. Now for question number second.
Sir, it is a vector space.
Vector space, okay.
फर्स्ट का सेकंड पार्ट या सेकंड क्वेश्चन?
फर्स्ट का सेकंड पार्ट.
सर ये सेकंड पार्ट वेक्टर स्पेस नहीं है क्योंकि इसमें आइडेंटिटी एलिमेंट सेटिस्फाई नहीं हो गए.
Yes, sir, it's not a vector space.
Is it correct?
So 1, 1 is the identity, I think.
0 0 0
First,
not belong.
okay, so before sorry,
0 0 0, yeah.
So if you want to say this is an identity element, you just have to use the word additive identity and multiplicative identity.
Additive identity.
Okay. Now, so you are saying it is a vector space or it is not a vector space?
So it is a
Not
vector
a vector.
space.
So
Not a
I
vector.
mean, one is saying it is a vector space, another person is saying not a vector space. So please clarify yourself why you are claiming. Before I am telling you the answer, but just verify, because there is a discrepancy in your answers, right? So why you are saying it is not a vector space?
स्टेबिलिटी लो होल्ड नहीं करेगा.
Because somebody is telling 1 1 1 will form the additive identity, and you are saying this additive identity you are unable to get the additive identity. That's the reason you want to tell. So you are telling that okay, this is not a vector space.
वेक्टर स्पेस में जो एलिमेंट होते हैं उसमें आइडेंटिटी के साथ एडिशन में वापस एलिमेंट मिलना चाहिए. अगर हम इसमें कोई वेक्टर लेंगे तो जो हमारी आइडेंटिटी होगी वो 0 0 होगी. इसमें ऐड करने पे वापस नहीं मिलेगी.
See, so okay, I understand. I got what you are missing here. So you are taking identity to be 0 0 0, but it is not the case of the kind 0 0 0. It can be. So here it may change. Only the identity is what? Additive identity is an element of the vector space such that x plus e equal to x for every x in V. Okay, so identity is a special element. If you add with any element of the vector space, it will give you that any element. Okay, so you have to find such an element if you want. So 0 0 0 is obviously not that element, that is identity. So it may not be the identity, but it doesn't mean that if 0 0 0 is not additive identity, it doesn't mean that it is not a vector space, because you can have 1 1 1 as a additive identity with you. So if you take e equal to 1 1 1, then you check. If you take any general element x1 y1 z1, you take any general element x1 y1 z1 and take x2 instead of x2 y2 z2, you take that 1 1 1. Will it giving this x1 y1 z1?
Yes, sir.
Okay.
Yes, sir.
So is it clear now? It is a vector space actually.
Yes, sir.
Yes.
With additive identity.
So if we take alpha is a scalar and u and b are vectors in R3, then alpha into u plus b is not equal to, I think, alpha b plus alpha u.
Yes, sir.
इसमें डिस्ट्रीब्यूशन प्रॉब्लम.
Okay. Okay, so you are saying that if you are taking scalar alpha plus alpha 1 plus alpha 2, please say it again.
I am taking alpha as a scalar and alpha is a scalar and u and b are vectors in R3. Then alpha into bracket u plus b is not equal to alpha into u plus alpha into b. Then, sir, in LHS side we have minus c constant terms, and in RHS side we have.
So whatever he is saying, is it correct? Those who are saying it forms a vector space.
Yes, sir. He's saying.
Yes, sir.
Okay, so maybe I also skip this this property. So it won't satisfy, but you see this, the additive identity is 1 1 1 and it is satisfying all the property with respect to addition, but it is not satisfying that property. Okay, so Yeah, so it is not a vector space because this property will not satisfy.
Sir,
Hmm?
sir, can you please repeat that property because I also calculated that it is a vector space.
So what they are saying, there is a so with the that scalar multiplication there are four property. Okay, if so one, if one is a that the scalar identity, the multiplicative identity, then 1 into x equal to x for every x in V. That is
Yes,
one
sir.
property. Another is C1, if C1 2 are two scalar, then C1 C2x equal to C1 times C2x for every x
Yes.
in V. Third property is C plus x plus y equal to Cx plus Cy. Basically that the scalar multiplication will go inside and then it is the sum. Now the third one, that the fourth one which they are saying it is not satisfied, that is C1 plus C2 times the vector x equal to C1x plus C2x. So they are saying this is not satisfied. I haven't checked that. These people are telling that okay, this
The
this
third
is
property, so alpha times u plus v is alpha u plus alpha v. Third property.
third property is not satisfied.
Yes,
Yes,
sir.
sir.
Not satisfied.
So I haven't checked it, but
Okay, sir.
if it is not satisfying, then it is not a vector space. Okay, so this is the third property, so which is giving you that okay, this is not a vector space. Okay, I missed it. For third one,
Not associated.
So it does not have identity element.
does not have identity element.
Yes, sir.
Additive identity.
So associative भी नहीं.
It does not have identity element. Is it correct? Zero. If you consider 0, 0, 0, isn't it the identity element?
No, sir.
No,
No,
sir.
sir. Unique
Why?
identity.
नो सर, कि 2 अल्फा आ जाएगा, कोई भी वेक्टर लेंगे वो उसका डबल हो जाएगा वेक्टर भी.
Unique identity नहीं मिलेगा.
Yes, yes. Okay. So, but there are you can also see there. It is not the only reason. You can check also the other for the other properties. Okay. So it is not a vector space. That is correct. Okay. And for the what about the fourth one?
Sir, it is not commutative.
Not a vector.
Yes,
Yes, sir.
sir.
Not a
Not
vector
not
space.
a vector
Not
space.
commutative. Okay. Yeah, so you can see here for so all of the above are not vector space over real. For question 2, we can just see for this question 2. Okay, so here we have to determine whether it is a subspace of V. So what do you mean by a subspace of a vector space?
अगर कोई सबसेट वेक्टर स्पेस का सबसेट क्लोजर होगा एडिशन के एस्पेक्ट में और मल्टीप्लिकेशन के एस्पेक्ट में ओवर द सेम फील्ड एंड सेम ऑपरेशन, तो वो सब स्पेस होगा.
You can say if W is if any subset of V is satisfy all the properties we have studied, that 8 property. If it is satisfying all the 8 property and it is a subset of V, then we can say it is a subspace of V.
इसे दो प्रॉपर्टी से भी कर सकते हैं ना प्रूफ.
One result. So
Yes,
if
sir.
I
One
have, let's say if I have two elements of a vector of from W, then their sum also must belong to W, and the scalar multiplication, if the alpha is a scalar from field and x is a vector from W, then alpha times x must belong to W. If these two properties satisfy, then I can say that this W is a subspace of V. Okay, so how we can prove this A part?
ए पार्ट
I
तब
mean,
होगा अगर
we don't
हमारा
have to
फील्ड
prove, we
रियल
have to check. I mean, we have to check. हाँ,
फर्स्ट पार्ट ए पार्ट तभी होगा अगर फील्ड हमारा रियल नंबर का होगा, क्योंकि कॉम्प्लेक्स में अगर हम आई से मल्टीप्लाई करेंगे तो हर मिशन मैट्रिक्स के
Scalar
लिए
multiplication not
फेल हो
satisfied.
जाएगा, नॉट सेटिस्फाई हो जाएगा स्केलर मल्टीप्लिकेशन.
Is it clear to everyone?
Why it is not
Yes.
forming subspace over a field of complex?
Yes.
Yes.
Yes, sir.
Okay. So yeah, you are correct that it will form a subspace over the field of real numbers, and it is not a subspace over the field of complex numbers, because yeah, you have said the reason. So what about this B?
बी पार्ट के लिए भी सेम वही है. इसके लिए
हाँ.
भी फील्ड हमारे पास रियल नंबर ही होना चाहिए, क्योंकि फिर भी फेल हो जाएगी स्केलर मल्टीप्लिकेशन.
Yes, correct. Okay, for C part?
सी पार्ट वेक्टर सबस्पेस होगा.
सबस्पेस होगा.
Subspace.
And मतलब इसे शो करना होगा, तो how will you show that?
अपर ट्रायंगुलर मैट्रिक्स के लिए कोई जरूरत
You, I
नहीं.
mean,
Addition,
why I
upper
am asking if
triangular
you.
matrix.
Sum of two upper triangular matrix must be
हाँ.
and scalar multiplication of upper triangular matrix is also upper triangular matrix.
Upper triangle matrix. So you just I mean, matlab, whatever you are saying, that is also correct, but you just keep writing these answers so that you are able to I mean, write it properly. Yeah, so it forms a vector space because any scalar multiple of an upper triangular matrix is again the upper triangular matrix, and the sum of two upper triangular matrix is again the upper triangular, because the lower part of the diagonal, the main diagonal, is 0. So 0 times 0 adds to 0 is again 0. So that's the reason. For D,
डी वाला होगा नहीं, क्योंकि अगर
No,
दो मैट्रिक्स
not a
इनवर्टिबल है
subspace.
तो उनका एडिशन करने के बाद वो इनवर्टिबल रहेगा ना, इसकी कोई गारंटी नहीं है.
हाँ, so you can
Yes.
take, you can
एग्जाम्पल
give
भी ले
some
सकते हैं.
example.
1 0 0 माइनस 1
10.
और आइडेंटिटी के साथ अगर हम इसको ऐड करेंगे तो जो मैट्रिक्स मिलेगी वो उसका
Identity
डिटरमिनेंट
and
0.
minus identity दो matrix.
Yes, yes.
Identity
Good.
and minus identity.
Yes, sir.
That also you can take as example. Yeah, good. And what about this E?
ई पार्ट भी नहीं होगा, क्योंकि सभी मैट्रिक्स अगर हम ऐड करेंगे दो मैट्रिक्स को, वो आइडेम्पोटेंट रहेगी नहीं, क्योंकि उसके लिए फिर बी ए इक्वल टू ए बी ए.
So if you so if you see,
Anti-commute
hmm.
10 only.
ए बी प्लस बी ए इक्वल्स टू 0 होना चाहिए अगर आइडेम्पोटेंट करना हो ए प्लस बी.
But that is not given here. So you can choose. I mean, you can take such an example so that AB plus BA is not 0. In that case, this doesn't form the subspace. Okay. So your answer is no. So see, I mean, these are not. These are very straightforward. These are not difficult. Example. Now for the question 3. So here you just focus on the vector space. V is here t comma t plus 1, all the tuples of this type where t varies over r. Okay, and the addition, vector addition and scalar multiplication are defined by these two equations. Now show V is a vector space. Have you done this question 3? If you have not done that, okay, you just write all the 8 properties. You just try to verify at least for one question that are you able to write that or not. So for question 3, you just consider it as your let's say the today's work. Just keep verifying all the 8 property that one told me for the vector space, and whatever you taught, I mean, you were taught in the class, you just keep verify for this given vector addition and scalar multiplication. Okay, it forms a vector space that you have to show. So now for the question 4. W1 and W2 are two subspaces of V.
W1 union
is the union.
W1 union union सबस्पेस नहीं होगा, क्योंकि दो एग्जांपल अगर हम
Union is a subspace if
may not be.
one is contained in another.
इसमें
But yeah, that is not given here. So
yes, generally
May or
not
may not.
true.
Generally not true.
May
So,
not be, we'll say.
How will you write that? I mean, if you want to show that this is not a subspace, then how will you say that?
Like
इसके लिए एक काउंटर एग्जांपल दिए.
So which counter example will you give? I mean, at least one you have to give, right?
वेक्टर स्पेस आर स्क्वायर लिया, वेक्टर
Just say
स्पेस
it one
आर
by
स्क्वायर ओवर आर ले लिया, तो W1 इक्वल टू A0 एलिमेंट टाइप के लिए, इसमें A0 बिलोंग्स टू आर स्क्वायर ओवर आर, और W के जो एलिमेंट होंगे वे 0B टाइप के होंगे over belongs to R square over the real field.
So you are defining over R, I mean vector space as R square over R, and you are taking W1 as x-axis and W2 as y-axis. That
yes sir.
okay?
और यूनियन करने के बाद क्लोजर प्रॉपर्टी फील्ड हो जाएगी उसमें, क्योंकि दोनों सेम एक साथ एलिमेंट मिलेंगे, ए बी टाइप के एलिमेंट.
So see, this forms an example.
Then 1 1 not belongs to any of the set.
You can construct other examples also. That is one example that is correct. That he's saying you can construct other examples also. In general, this W1 union W2 is not a subspace of V. Okay. And what about this B?
B पार्ट के लिए टू स्टेप वाली प्रॉपर्टी लगा करके जो
first you tell me it forms a subspace or not?
Yes sir.
Yes sir.
Yes.
It forms subspace. Yes.
intersection of two subgroup
So how will
subspaces. इसके लिए क्लोजर प्रॉपर्टी और क्लोजर प्रॉपर्टी ओवर द एडिशन एंड मल्टीप्लिकेशन प्रूफ कर देंगे.
So is it clear to everyone? This is easy, right? You can if you take x and y in W1 intersection W2, and you have to show that alpha times x plus y belongs to W1 intersection W2, or you can say if x and y belong to W1 intersection W2, then you have to show x plus y belongs to this and alpha times x belongs to this for every x in V. That much you want to show. Now it is easy since this W1 and W2 are given to be two subspaces, so their addition will also contain in this and this, so hence in the intersection. Similarly with the alpha times x and alpha times in both the intersection. So by that reasoning you can easily say. Okay, so okay, yeah. So for question 5.
So disprove. Disprove.
Disprove. What about others?
Prove.
So in order to disprove some statement, you need to give some example, counter example. So are you proving or disproving? First you tell me. So you're disproving, 2% are saying disproving. What about others? So first you understood the question. What does this question demand? So first you tell me, what do you mean by if W1, let's say if W1 and W2 are two subspaces, what do you mean by W1 plus W2?
So W1 plus
Sir,
W1 plus
W1 plus
W2
W2 is again a subspace of
W1 W2, where W1 belongs to capital W1 and W2 belongs to capital W2.
Capital W2, yes. So first of all, it is the collection of all the elements of the type small w1 plus small w2, such that small w1 will contain in capital W1 and for W2 also. Okay. Now it is given that this W1, so these three are the subspaces of V. Is W1 plus U equal to W2 plus U. This statement is saying, it is claiming that W1 equal to W2. So is it correct?
No sir.
No, sir.
How will you justify your answer?
Sir, we can take the two subspaces of R2.
Which subspaces?
W1 is equal to 1 is generated by 1 0 and W2 is generated by 0 1.
You should not use the word generated actually.
Sir, x comma 0 where x belongs to R.
That in that way you can say generated is not actually not defined. We haven't defined that word, but yeah, you can write like x comma 0 where x is in R.
And sir, W2 is 0 comma y where y belongs to R. And sir, we can take U as a vector space x comma x where x belongs to R.
comma y.
Right.
Yes, sure. And then W1 plus U and W2 plus U both are same vector space with
Yes.
same subspace of R2, but W1 is not equal to W2.
So we can take U as a trivial, so it will directly disprove.
You are saying if you take U
But
as
in
a
that case, W1 plus U will not be equal to W2 plus U, na?
Yes.
Say it again. Hello.
If we take trivial, then first condition does not follow. W1 plus U equals to W2 plus U. It should be satisfied then.
Yeah. So for the you can. I mean, you have to take an example. So you are taking, like, let's say W1 and W2 are two different, and U is a trivial subspace. Then
Yes, sir.
it is not following. Okay. So it is basically we are disproving this by supplying an example. Now, do you have any classes after this? Because the
No,
time
sir.
is already up.
No, sir.
Okay, so you just do that. The next question, that is basically if you replace this plus sign by the direct sum. Okay, then what is your answer? If W1 plus, so basically here the normal plus is replaced by the sign circle of sum, that is the direct sum. So we call it as a direct sum. Then what will be your answer? We will discuss in the next tutorial. So have you done this question?
No, sir.
No, sir.
No, sir.
Any idea? So you just think about this question, because direct sum, I think in today's lecture you have studied, right?
Yes, sir.
Yes.
Yes, sir.
So just try to write answer, because if you can already see that this question fifth is not true for for the normal sum. Okay, and so
Then this also we know.
so why I am telling you, just think on it. It is true or not. Okay, independently. Just don't discuss with you. Just see your notes. I mean, whatever the reference you want to, and you just see the definition, and just by your logical reasoning, you just try to answer this. Okay, because you are telling me some, okay, we can take trivial space or something. Okay, just think about this question. So you have two things. For the question 3, you have to try this question 3, all the 8 property. You just write in your notebook or whatever. It will be helpful the answer to write the answers in your for the exam point of view. Okay, just write the answer for question 3. I'll ask in the next tutorial, and for the question 6, what will be your answer? Okay. For question, yeah, yes. For question 7,
क्वेश्चन नंबर 7 के लिए 8 प्रॉपर्टी जितनी भी थी प्रॉपर्टी सबको सबको वेरीफाई करना.
So basically you can say that, I mean, for question 3 you can do question 3 or question 7. I mean, you have to show that it is a vector space for the given operation. So you can also consider this question. So you can see this question, because this question is it is the elements of this vector space are not the vectors, the usual vectors that we always see. These are basically the functions from real to complex numbers satisfying this rule. I mean, this f of minus t equal to ft bar. So you just verify by yourself. I mean, it is not like we are here to like write all the answer, and so it is like these are practice questions for you. For question 6 we will discuss in the next tutorial. First you just think independently. So you already have the answer for question 5th, and what is the answer for question 6, you should think about it. Okay, then we will discuss, so we will stop here and we will discuss some next question. So these are the next part of the tutorial 2 will be from basis and dimension. So these topics are not covered, right? These basis and dimension.
No, sir.
No, sir.
No,
अभी
sir.
कोई-
So till the next tutorial, we are able to finish this sheet 2. You just try all the answer and write for the question 3 and 6. Think about question 6. What should be the answer? Okay. Okay. So we can leave. If there are no.
Thank you, sir.
Yeah. Thank you.
Thank you, sir.
Yes. So see here, we are also trying. So in one question, we are okay. I am also saying that okay, this forms a vector.